Hello guys, welcome to my YouTube channel. In the last video we have discussed about the meta features and then we visualize and get an inference. That's what we did and we implemented that's in the code. In today's video, because the next step is that we going to implement the n-grams in our case study. So before implementing the n-gram, it's good for us to know the mathematics behind the n-gram. So for this only I create this video. This is the short introduction regarding the n-gram. What is the n-gram? What the mathematics behind it? I will cover in this video. Then we will implement this theory in the next video in our case study. So basically it's just an introduction about the n-gram. So let us start this video to define what's the n-gram first. As we know, in our daily life we encounter some kind of application like the auto spell check, grammatical error correction, machine translation, auto completion during email writing when we write in our emails in a Gmail or Yahoo. So these all four applications which we face daily in our lifestyle all are based on the probabilistic model of sequences. So the probabilistic model of sequences could suggest the word which is more probable in the given task. So actually the model which assign the probability to the sequence of words is known as the language model. And among the language model which assign the probability to entire sequence of word or which predict the next word by seeing the history of your sentence is known as the n-gram. So basically n-gram is nothing, it is a contiguous sequence of word from given sample of a text. So if we change the value of n, the definition of if you give n equal to 1 then it become the 1 gram. If you give n equal to 2 then it become the 2 bigram. If you give n equal to 3 then it become the trigram. So 1 unigram means it will be say like 1 token or 1 word. Bigram means it use the 2 words like please turn, that's 2 words in this. So please turn, this is a bigram. Your homework is again bigram. But what is a trigram? If we use the 3 words together, please turn your, or we can say turn your homework, because in both the things we are using the 3 sentences, so we say it is a trigram. Then there is another come when we increase the value of 4, then 4 gram, 5 gram and up to the n gram. But one of the most important things comes in this n-gram model is that how we can estimate the probability of the upcoming word. So for this, if I take an example, the sentence is its water is so transparent that, and I want to predict the upcoming word, and I say the next word is the. But how I can say the next word is the? What is probability? What is the probability? This next words come the. It's our task to calculate the probability. So to calculate the probability for the, by seeing the history, its water is so transparent that we can calculate the probability by the 2 method. One is the conditional probability, that you have to be what you want to predict. You want to predict the word the, and what is your history? Your history is its water is so transparent that. That means we easily can calculate the conditional probability. So the conditional probability is one method. So the word is the and the history is water is so transparent that. But there is a problem. What is the problem? We do not have the large corpus of data set. Even if you talk about the web is also not a large corpus of data in case of the when it comes to the natural language processing. Why? Because the language is so creative. All the times new words are created, new sentences are created. That means if we use any kind of a data source, if we use any kind of a corpus to get this estimate that the next word will come the, we do not have a good estimate there, because we not have a large kind of a data set in case of the NLP. As this handle only about the text, language, and in the language all times new words are created. So that's the reason conditional probability we can't use. So what we can use else, as I told, there is a 2 method we can use any of two methods. So next method come is the joint probability. In the joint probability, what you can do, you have to be count the same like how many of the words, how many of sentences are like its water is so transparent. Out of them you have to be calculate the next word come that sentence. But if you perform the joint probability operation in this task, then there is a lot to estimate, there is a lot of calculation you have to do, lot of the things you have to do. So joint probability is also not a good idea. Now, to predict the next word, we have two methods. One is a conditional probability, that's we reject, and another is a joint probability, that's also we reject. So we have to be find the solution which can calculate, which can predict the probability of the word the. So for this, we come to the solution and we tell we can use the chain rule of a probability, because the chain rule of a probability is what we can use as a conditional probability also in that, and we are using the joint probability also in that. But do you think that using the chain rule of a probability our problem will resolve? According to me, the answer is again no. Why? Because the conditional the chain rule is also again using the conditional probability, and as I told, we do not have a good estimate to predict the probability in case of conditional probability. So that's the reason we do not have a solution for this problem to predict the next word probability if we use the n-gram models, because the n-gram models is basically a very simple model of a language. We have a good models, we have an RNN, we have an LSTM, we have a BERT, Robert transformer based model in nowadays. So this n-gram model is not much powerful, that's the reason we called it n-gram in place of the n-gram model. Okay, now if I talk about particular case, say the bigram, because the word our sentence is what is water is so transparent that the next word we want to predict the. Now if I talk about only, I want to use the bigram here, that means I am going to use only the two tokens, so I can't use the full history, only I can use the word the and the one previous word, that is that. Okay, so probability of the given that why I want to calculate in the case of the bigram model. So this assumption, like you have to use only the one word that is in the history in place of the whole history. What this assumption called? This assumption is actually the Markov assumption. So what is the Markov assumption? It's predict the probability of the future words without looking too far into the past. That is the Markov assumption. Now why I'm discuss these things here, because suppose you showing your case study to somebody else and they ask, okay, you perform the n-gram in your case study, what's the assumption bigram model makes? And if we do not know about what the assumption makes, then it's all waste. And if we know, okay, it's a Markov assumption the bigram model makes, then what is the Markov assumption, that also we should know. So Markov assumption is that we predict the future word without looking too far in the history, that is the Markov assumption. And another thing what can come, how do we can estimate the probability in case of n-gram? So we have a method called the maximum likelihood estimate. We get an account from the corpus of our data and then we can normalize it, so it come in the scale of 0 to 1. So that's the way we can estimate the n-gram probability. So what is the intuition of the n-gram model? As we say, we can't use this n-gram model to predict the next upcoming word, because this is very basic word. So in place of predict the next word, we can approximate the history by the last few of word. Anyhow, we can't predict, but we can approximate the history. So in that sense, we can use the n-gram. And why I want to show you the n-gram in my case study, because still we not perform the data cleaning in our case study, but I want to show like if I we going to perform the unigram, bigram and trigram, I want to show like what's the percentage, how many times the word come in our text, because we have a text that is a tweet text we have. So basically this is the very short video and a very introductory video for the n-gram model, say the n-grams, and I hope you like the intuition and the mathematical concept behind it. So what two most important questions come here? What is the n-gram model and what is the assumption bigram model makes? And if you know the assumption name, that is a Markov assumption. That what is a Markov assumption? The next thing come, how to estimate the probability, that we can say with the help of the maximum likelihood estimate. Okay, how the maximum likelihood estimate works, that is a different topic for the statistic. That one I will cover in the later of the videos. But my idea for this video is to give an introduction about the n-gram. So in the next video, when we implement the n-gram in our case study, we do not restrict like what is an n-gram. So that's my idea. And this is the fourth A part of the video series, and the next fourth B part is we are implementing the n-gram in our case study. I hope you like this video.